So today we're going to talk about objects. It's all about objects today. And going forward, it's going to be so much about objects because we said Java is an object-oriented language, and we spent the whole first week and we didn't really talk about objects. Okay, so when we talk about objects, there's a lot going on with objects in the sense that we have objects and we have instances of objects, which we're going to talk a lot about. So today we're going to focus on understanding the 5 basic properties of object-oriented programming. We're also going to talk about abstraction. And abstraction was a tough concept for me to understand early on because normally we want to talk about very specific things and how we do specific tasks and what specifics are in the object. But I'm going to ask you to open up your mind to think about abstraction as something that allows us to not be specific about the instances of the objects that we're going to create. So it helps people understand what is available to them. Then when they come and use this abstract class that we're creating, they can then get more specific about how to use the instance. In other words, if I say that every car has a color, that's abstraction, right? I'm just saying, well, I'm not telling you what color your car has to be because I can't. If I right away define every car to be red, we would have nothing but red cars available. But if the car object has a color, it has to have a color. I know it needs to have that color. Every car is going to have a color. But now when I use that new keyword and I create a new object, I can decide if my car is purple, orange, green, polka dots, whatever it might be. Now we have the abstraction of the class, but the actual implementation has the specifics. Another thing that we've been talking about has to do with how data is a highly typed language. Again, it's not the amount that we have to type in on the keyboard, it's the data types. We talked about int, float, double, Boolean. These are all primitive data types that are important that we use most often when we're creating variables, right? We said that we need to know what the data type, so we will understand what can go into that data type so we don't try to put a square block into a round hole. So now, we also said that in Java, or if we haven't said it, I'm going to say it right now, all things in Java need to have a type, right? So we're going to talk a little bit about what that means when it comes to objects. It makes sense for variables or primitive data types to be easy enough to understand that an int is going to be a whole number, a float is going to have decimal points, and so on and so forth. But what about an object, like the car object that we just talked about? What kind of data type is that car object? And we're going to talk about. So we're also going to talk about something called encapsulation, and you'll hear that as a term that is going to be important in object-oriented programming for any language that you use, and we'll talk about what that means. So let's go ahead and start with abstraction. We have situations in the world where we have abstraction, and what I was saying before is that what we want to tell people is that we're going to tell you what is available, but we're not going to tell you every specific detail about how to implement. We do that in ways with things like blueprints. Some other example would be instructions for different, let's say you go to IKEA and you get a dresser and it comes with a set of instructions, and it's not every single piece of what you need to do. It's not going to tell you to pick up the screwdriver, place the screwdriver into the Phillips head of the screw, turn it to the right 27 times. It's going to tell you that you need to screw that side of the board into another side of the board, and it's going to keep it on a higher level. It's not going to tell you if your screwdriver has to have a red handle or a blue handle, but all these things, if you had to, you would be bogged down with, instead of trying to solve the problem, which is creating a piece of, assembling a piece of furniture, now you're down into the minutia, if you will, of all these details that you don't really care about in the ultimate outcome of what you're trying. So just kind of bear with me on that. We're going to see, I think we're going to see more of this about as we start to create some of these classes. That's what Java gives us, the ability to abstract out the classes and then let the implementation be handled more at the specific level when the objects are created. Okay, so sticking with that train of thought here, again, we're really talking about all programming languages use abstraction on some level. It's just that some programming languages are more closely related to the functions of the computer than object-oriented languages are. Assembly is mostly functions, from what I understand, and line-by-line functions to do that. We don't want to get involved with all of that. We want to think about how we can actually solve the problem and let our object-oriented nature of the Java language help us to do that without focusing on changing the problem to match the implementation. So when we talk about classes, instead of talking about how to solve things, we're talking about objects that can do specific units of work for us, and we can tell by what type of object it is and how it's defined, how it might help us. So here we have a bunch of standalone objects, and what I mean by standalone objects is right now they're not really working together. I want you to keep in mind, I know I've said it before, I'm going to keep saying it, is the Java language is a whole bunch of objects that are designed to do specific and rather narrow tasks, but then to integrate with each other and communicate with each other so you can solve bigger problems. So we can see that there's a lot of functionality in what the monitor does. Each one of these has state and behavior, right? State is going to be the status. It's going to be the variables, the items that define the makeup of this class, and then the behaviors are going to be in methods. So you see why we spent so much time last week talking about what types we can have and what variables we can create as member variables. And then we also spent a lot of time on methods and understanding how we can create methods, the different forms of methods that we can create, and those types of things that will give us the behavior of the object. So continuing with that thought, in object-oriented programming, everything is an object, okay? As I was just saying, a program is a collection of objects. Each of the objects can be made up of other objects. This is a strong statement. Think about that for 1 second. And while we're thinking about that for a second, let's go back to this, right? I was saying that these are all standalone objects. Right now, these objects are individual objects, and they might need to be individual objects. I might need a phone inside of an airplane. I might need a phone inside of an office. Right? So the power of being able to put that phone object into an office, back to the example I was mentioning about the has-a. And if you think about it, to say an object in an object, the easiest way to figure that out would be to say an office has a monitor, an office has a keyboard, an office has an office chair, right? But the biggest power of all of that, if I couldn't put those objects into my office object, I'd have a problem, right? Because I have an office, I need to be able to pick up the phone and make a call and receive a call. I need to use a keyboard. I need to use all of these things in my office. But if Java and other object-oriented languages didn't allow me to put those things into my office, I'd have to write each one of those in my office myself. And how would I know how to write the details and the implementation around a phone, right? Think of all the lines of code that have to go in that object that I'd have to now write inside of my object. Let's say 500, probably way more than that. But let's say 500 for each one of these, right? Now I've got 2,500 lines of code in my object, and now I have this monolithic class that if I ever need to maintain or figure out what's going on, it's going to be a disaster trying to go in there to figure it out, right? We want those things to be specialized, smaller units of work as objects that can be used in other objects or at least be able to communicate to other objects. And that's the power of being able to use objects in other objects. We are going to talk more about that, and I should mention that When you put one object into another Java object, that's called composition. And again, the fastest way to figure out if an object is in the class would be to say that I'm going to use the has a term to figure that out. Now, on the flip side of things, if I had, let's say I had an automobile object, not depicted here in the picture, but for some reason that this is maybe a bad example, but this automobile object has a great way to just touch a button on the dashboard and it prints something. So as an office, it wouldn't make sense for me to bring an automobile in here to do just one task, right? So we have to be smart about what objects we bring in and do they make sense in the context of the parent object that we would want to bring that in. So those are all things we're going to talk more about. But for now, this all makes sense, right? If your object clearly needs all of these specialized individual objects, we can bring them in. But the next thing I want to talk about is, like I was saying, is if we're saying that everything in Java is an object, and we're saying that Java is a highly typed language, every object has to have a type, okay? And all objects of a particular type can receive the same messages, right? So if I have two objects, if I have two phones, I may need to have two phones, right? Maybe I have an executive phone and I have a warehouse phone. The warehouse phone has a few different features. Maybe it is sturdier so things can fall on it or whatever the reasons might be. I'm still going to have similar methods inside of that object because when the phone object was created, it was created with abstraction and it was created in a way that it focuses on that phone class being a template to give the implementation the opportunity to say, okay, I need all of the functions that are happening, all of the methods that are happening inside this phone. I need to call out, I need it to ring, I need to be able to receive and make calls, all the different methods or behaviors of the phone. However, I can now decide that I'm going to give one a particular slant and more specifically to be a warehouse phone as one would be an executive floor phone. And that's the power of using abstraction because we're saying that the phone needs to have the specific state and behaviors. And then we're saying you can now instantiate or create new versions, instances of the class. And when you do that, that's when you bring in your specifics.